Okay, this is lecture 9. We're going to talk about something called Visual Basic Structures. It's a continuation of what we talked about when we were talking about uh, arrays, which we called a complex data type, and the visual basic structures are also complex data type. Remember that primitives are things like the simple data types that we've talked about in the past, like strings and integers and doubles and so on. But arrays we called a complex data type. So in the last lecture, we began discussing complex VB data types, in which it wasn't actually the last lecture, it was the previous one. Last lecture we did uh, certain kinds of, well, actually, I'm sorry, no, last lecture, it was last lecture, in which we combine several primitive data types uh, of either the same or different types together to make a more complicated data structure. We had an in-depth look at our first such data type, visual basic arrays, in which we construct and use an indexed array of objects, all of the same type. And we talked about declaring and initializing and resizing and using those arrays. And we also talked about the for each loop, and we used that, remember, to initialize or to give a value, populate an array. An additional loop flavor designed specifically for working with lists. In this lecture, we introduce structures, which allow us to combine several primitive data types together into a single newly defined type. So structures are often defined separately from the GUI or from the form in a separate class file. For example, we're going to define one today called customer.vb, and this is to enhance clarity, reusability, and portability. However, structure could instead be defined at the top of Form 1, much as we defined our day action enumeration before. To define a VB structure, we use this syntax, and just like Form 1, it's a class, which was a class structure. Structure members can include fields, so classes have fields. Those are structure level variables, properties, and methods, custom subroutines and functions. Each is declared using the public or private keyword to specify the visibility. After defining our structure, we may declare a new instance via the dim keyword. So just like we can use the dim keyword to create a new integer, once we define a structure, we can get an instance of that as well using the dim keyword. You'll see in a minute or two. Or alternatively, as a member of a form. We will now discuss this more clearly by example. At this point, open Visual Studio and create a new WinForm application called Structure Demo. So open up, let's do that together maybe. So we want to open up just a regular project, and then and you can call it Structure Demo. I didn't call mine Structure Demo, but you can call your Structure Demo. And then add a new item to our project. I don't think we've done this before, using the Solution Explorer. So right-click on your project. So that's over. Let me see if I can bring this. It's over here. So right-click and add new item like that, like this. And next, so you add the new item, and then create an empty class file named customer VB. So down here, can call it customer.vb, and then add. So now you get this over here, and here you get this here. Okay, so we haven't done that before. And next, add the code for the structure into this customer class. So we're going to create, it's like creating a new data type. It's like creating a new data type, like integer is a data type. We're going to create a new data type. This data type is going to be called customer. And it's going to have several members or several different fields associated with it. So it's going to have a first name as one of the fields, last name as another field, age as another field, and email as another field. And each of these fields are of familiar types: string, integer, and string. But this new data type, so to speak, is structure, is a customer type. So he says add code for customers for members. These are referred to as members. Each will represent one structure instance attribute. So it's like a property. But a little bit slightly different. We declare 3 strings and 1 integer. 3 strings and 1 integer. Control the visibility of each of these by declaring using the public keyword. Each will be accessible outside the structure's code using the dot operator. So we'll be able to access these because they're public outside of the code. So anywhere in our project. Now let's set up our GUI logic and place our controls. So you want to set this up. So we have 5 labels, 1, 2, 3, 4, 5, 5 text boxes, and 1 button. And set the control properties. So the labels that the text of each is shown. Text boxes as usual to match each label. Text name, text first name, text last name, etc. And btn test. Okay. Goal, support display and entry of members of a single customer structure. So you can see that this represents a single customer, and you can see that these fields here will be the basic fields for a customer, right? They have a first name, a last name, age, and email. However, we have one extra text field here, and one extra, so a name, which we haven't included here, right? We have first name and last name. We have first name and last name here. We have name here, which we haven't included yet. Okay, now let's add controls to form 1. So we're going to double-click the button, and we're going to make a new customer instance. Okay, now what does that mean? Well, remember I said that we're kind of creating a new type of data type, a new data type, and so we can create an instance of it, just like we can create an instance of an integer. So, and we did that with enumerations, if you recall, in the past. So we just do dim, and we'll call it test customer, but it's as type customer now. That's something new, but although we did kind of do the same thing with enumerations. Okay, now set up the instance. So this customer has 4 fields, right? So we want to assign values to all of the fields. We have an instance called test customer, but this is like when we have a button, or let's say when we have a text box, we can access different properties of the text box with the dot notation. So we can do like textbox.text, text box color, maybe, I forget the other one, all the different ones, but we use the dot notation to access the different properties. Now we have a test customer which has various properties which we've set up, and those properties are first name, last name, age, and email. And now we can assign them just like we assigned values to the different properties here. And now, after we've done that, now we're going to make a method that takes a parameter of type customer. Now we've written some methods before. This is a subroutine, it's not a function. We've written some subroutines before, I believe, and we've said what kind of parameters they can take, like a subroutine might take an integer as a parameter. And we even talked about, when we were talking about arrays, a subroutine could take an array as a parameter. We talked about that last week. So now we're going to create a subroutine or a method that takes a customer as a parameter. So that's interesting. And since the parameter type is customer, and the name of the parameter, the local name, remember, is temp, we should temp, so we're going to put, so this method needs to accept, or needs a customer type in order to act on it. So this should be of customer type. So if this is of customer type, then it has a first name property, it has a last name property, it has an age property, it has an email property. So it's okay to address those or to reference those. And that's what we're doing here. I'm referencing, since this is of customer type, I shouldn't put something in display customer if it's not of type customer, because it's expecting something of customer type. So I'm going to put something of customer type in, but if it's of customer type, it has a first name, a last name, an age, and an email. We define customer type to be like that. So then I should be able to reference those, and that's what I'm doing here, temp.firstname. So it means whatever we're putting in, we're referencing the first name of it. Whatever we're putting in, we're referencing the last name and the age and the email. And then what are we doing with the first name of the customer? What are we doing with the last name of the customer, with the age and the email? Well, remember, where is all this code taking place? It's taking place on form 1. Now remember that we defined the customer structure somewhere else in the customer.vb class, if you recall, which was not in this particular form, if you remember how we did this. So, but where is all of this happening? This is happening on the form. So when he writes me, it means this current form. So it's me.text first name.text. What does that mean? Well, this is the name of what? That's the name of this text box. What's this text last name? That's the name of this text box. What's this text age? That's the name of this text box. What's this text email? That's the name of this text box. Me dot those things means this particular one, this particular one, this particular. Now sometimes they say you don't have to write the me, but it's clear if you do write it. So anyway, so what? Now this function accepts a type of type customer, accepts a variable of type customer. So it has a first name, last name, And now what we're doing is just accessing those particular properties of the customer and assigning them to the text properties here. Okay, so that's what this function will do. So now we've defined this function, but we haven't used it yet, or I haven't talked about using it yet. But we don't want to just define a function but not use it. That wouldn't be very useful. But we do use it right here. So we say display customer, test customer. So what is test customer? This was the example of the customer. We called it test customer, and we actually assigned values to it. Okay, so he says you can test this by testing this button, but name is still blank. So he says, but what about name? So now we're going to talk about adding properties to structures, and that's the name is going to be a property as opposed to a member. As we have seen, structures are defined to have members. So the members were these four. Text. Well, let's go back here. We're actually here. So these are the members here. And these express the structure characteristics, right? So the characteristics of our particular structure, which is customer. So our customer has a first name and a last name and an age and an email. Those are characteristics of a customer. So these express structure characteristics, and they may be public or private. Here we chose to make them all public. In our example, we just accessed structured members directly. So what he means by that is we used the dot operator. We just used it here. So we could access this structure, temp.firstname, that member directly just using the dot notation. Sometimes we want to prevent that from happening. And then we make what's called a property for our structure. And that's what we're going to do now. So, and the idea is that we don't want to allow someone to enter the name. We want to control it. We want the program to control it. So the access to this field is kind of denied to the user because we don't want someone's first name to be Taro and their last name to be APU, but their full name to be John Doe or something like that. We want it to be Taro APU, right? So we want to control this to some degree, okay? Because it's supposed to be the combination of this and this. We don't want to allow someone direct access to this member or this field. Okay, so that's the idea. So however, members may be handled indirectly via properties. These abstract away member details, or another, they kind of hide the details. We saw this for classes last lecture. We may also, I'm not sure if we saw this or not, but we may also define properties for structures, properties for structures. So we saw that for enumerations. We talked about defining a property for an enumeration, and we use this kind of syntax, and we have a get method and maybe a set method. Now, in this example, we're not going to have a set method, but we are going to have a get method, and this approach will prevent, first of all, you can't access the name property directly with the dot notation. That's one thing. And also you can't even set it. It's only going to be set by way of the first name and last name being set here. The get and set methods are both accessed via the dot operator. Okay, next let's add a name property to our customer structure. So we already had this, we already had that, we already had this, we already had this, but we're going to set this name property. So we're going to use this public read-only property name as string. So it's a little different declaration than here, right? This was just public first name as string. This is public read-only, that's a keyword that we can use. And then property as property name as string. So that's new, property. And then we have to, if we do that, then we need to define a get method. So that means when someone accesses this name property, what should they get? And we're going to define it. You have to have the return keyword there. And then me refers to the form. And then first name me.firstname means, me refers to the structure, and me.firstname means the first name of the structure, and me.lastname means the last name of the structure, and we're just concatenating first name and space here and something. I guess that's a hyphen and the last name, right? And then end get an end property. Okay, so we're defining a property like this, and then we have the end of the structure here. Now we're going to do this. We're going to update our Form 1 code. We already had this, and this before in our sub, but now we're also going to reference me.textName. That's the that's this one here. We're going to reference that. And temp means that we get a customer, and .name, but name is a property, and here it's defined, and what it returns, this property is like basically, well, we have the get function, so it's a kind of a function, a method. So we're saying what it gives back, and what it gives back is first name, I don't know, is this a hyphen? Last name. So that's what will be filled in here. Okay, so let's read what he says. Here we add a new name property to our structure, and the visibility is public, but we make it read only. In this case, we may define a get method. We will return a string equal to first name plus last name, but no set method. So we're not allowing it to be set. This is an example of a composite property. Its value is dependent on the values of other members, right? So it depends on first name and last name. So those are other members. First name and last name are other members. This is an example of a composite property. Its value is dependent on the values of other members. This is ideal for managing a customer's name since it should be set by changing the first and last names. Okay? Here, the access here to the name property, and here we access the name property and pass its value to textName.text. The arrow shows how the call to temp name is resolved. So when they say temp name, it gets these. And so now, if you test it, this will be, I guess it wasn't a hyphen. This will look like this. But the thing is that this cannot be accessed directly because we made it into a property and read only. Okay, so we talked about structures, and structures are very close to what are called objects, and so this is a good time to talk about objects. So a related complex visual basic data type is the object. We haven't created our own objects yet. We just created a structure, but we've never created our own objects, but we've used them very often. Whenever we create a Windows application, we get a Form 1 object, so that's an object. Form 1 is defined between the keywords class and end-class. Very much like Visual Basic structures, objects are defined to have characteristics, fields, and properties. Fields are class-level variables, and by that he says they're much more permanent than local variables, and also properties. And we also have behaviors, he means methods, and we've already seen these, for example, event handlers and user-defined methods. Due to their similarity, computer languages treat structures differently. Java does not even have structures at all. So Java doesn't have structures, they just have objects. In C and C++, structures are pure data types, which means they don't have methods, but in Visual Basic they do. In Visual Basic and C#, we have both. It's important to know that objects behave very differently than structures. What he means by that is, remember we had a discussion about reference types. So objects are reference types, and that was just like arrays. And remember, that means that they change or disturb the original um, uh, object or the original array. So passing an object instance into a method by val passes a copy of the reference to that object. Changes made locally will affect the original object. Okay, structures are value types. That's different, just like BB primitives. So passing a copy of a structure into a method by val passes a copy. In this case, changes made locally will not affect the original structure. Now, if you do by reference, it will. But by val, behaves like you would think. Whereas if it's a reference type like the arrays or objects, then it doesn't behave like you would think. Even if you use by val, it still disturbs the original. So which do we use? A basic guideline is as follows. Classes are most useful. So which do we use? Do we use objects or structures? Classes are most useful when behavior is important. So he means classes, he means objects. I think he meant objects here. Structures are useful when behaviors are not needed, and space is important. This situation is much more complicated. However, for now, this discussion is adequate. However, know that objects are critical for modern programming, and we'll cover them more in programming too. Conclusion. This lecture, we continued our discussion of complex Visual Basic data types in which we combine several primitive data types, i.e. of either the same or different types, together to make a more complicated data structure. This time we learned how to define our own Visual Basic structures, which allow us to combine several primitive data types into a single newly defined type. So what was that? We created a customer data type. It was a structure, and it had several primitive data types in it. I think it had one integer field and 5 string fields, and we also discussed their similarity to and difference from objects.